Hi everyone, and welcome to Geography with Mr. J. In this session, I want us to focus on some basics that will help us gain a better understanding of climate and weather. There is a relationship between air temperature and air pressure. As seen by the arrows, temperature and pressure move in opposite directions. As temperature increases, air pressure decreases. In other words, the warmer it gets, the lower the pressure becomes. In the same way, when temperature decreases and becomes colder, pressure increases and becomes higher. Again, I like to think of temperature and pressure as not being good friends. They move in opposite directions. Remember those questions where you are asked if a synoptic weather map represents a summer or a winter situation. One way to answer this question is to look at the pressure cell over the interior of South Africa. In our example, the low pressure over the interior was created by an increase in temperature. Temperatures generally increase during summer, so the synoptic weather map represents summer conditions. In other words, that low pressure there was created by warm conditions during the summer months. As you progress through the grade 12 content, questions around weather changes that are brought about by a cold front will arise. As the cold front brings with it cold air and colder temperatures, it means that it also brings along higher pressure. In this instance, the temperature at Cape Town, for example, will decrease, but the pressure will start to increase. It is vital to remember this relationship between air temperature and air pressure. The pressure gradient force explains the movement of air from an area of high pressure to an area of low pressure. In other words, wind, which is moving air, always blows from a high to a low. It is also important to remember that winds are named according to where they blow from. For example, a southeasterly wind originates or starts in the southeast. Berg winds, for example, start over the interior of South Africa, blow down the mountains or the bergs of the escarpment towards the coast. For berg winds to develop, we require a high pressure over the interior and a low pressure along the coast. The location of the high pressure and the low pressure sets in motion the pressure gradient force. Interestingly enough, berg winds are a winter phenomenon. If you look at the map of South Africa, you will notice that over the interior we require a high pressure in order for berg winds to develop. That high pressure results from colder temperatures during winter. During the course of the grade 12 year, you will be introduced to what are called anabatic and katabatic winds. Anabatic winds are also called valley winds as they originate on the valley floor and blow upslope towards the top of the valley. For this to happen under the pressure gradient force, the high pressure has to be in the valley and the low pressure at the top of the slope. So what exactly creates this low pressure at the top of the slope? During the day, there is an increase in the temperature at the top of the slope as the sun heats the top of the slope first during the day. There are two important facts to remember about fronts. Number one is that fronts always separate cold and warm air. Whenever you see a front in a diagram or on a synoptic map, remember that there is cold air on the one side of the front and warmer air on the other side of the front. The only reason why fronts appear or exist would be to separate warm and cold air from each other. Secondly, all fronts always produce clouds and eventually rainfall. So whether you work with a cold front or a warm front or with a polar front and later on with what is called a moisture front, what all these types of fronts have in common is that they separate cold and warm air from each other. And in all cases, these fronts produce clouds and rain that will eventually fall along these fronts. So what impact does a cold front have on the weather at Cape Town, for example? Number one, this cold front will bring cold air to Cape Town. Therefore, the temperature at Cape Town will drop and decrease. Number two, if the temperature drops, then the air pressure at Cape Town will increase. Thirdly, the front will bring cloudy conditions to Cape Town in that the cloud cover will start to increase, and the front then also brings along with it rain over Cape Town. And in the case of the cold front, the rain will come down quite heavily. Moisture fronts occur diagonally across the interior of South Africa. Cold air from the Atlantic Ocean meets your warmer air from the Indian Ocean. These two air masses are drawn towards the interior of the country by the presence of these low pressure cells. If there are low pressure cells over the interior of South Africa, can you guess during which season moisture fronts develop? That's right. The low pressure over the interior of the country indicates that the temperatures have increased, and temperatures generally increase during summer. Importantly, along this moisture front, we're going to have the formation of cloud, and from these clouds, we're going to have rain falling. And in the case of these moisture front and cloud formation and rain, the rain is in the form of thunder showers. So it's important to remember that fronts always separate cold and warm air from each other, but that fronts always have cloud and rainfall occurring along. Of equal importance is an understanding of low pressure and high pressure cells. In grade 12 especially, we will deal with well-developed low-pressure systems like mid-latitude cyclones and tropical cyclones, as well as 3 high-pressure cells that impact our climate and weather. To make it easy on myself, I try and memorize the characteristics of a low-pressure cell, and then remember that the characteristics of a high-pressure cell are generally simply the opposite. Let's have a look at the characteristics of a low pressure cell. A low pressure cell is also called a cyclone. In a low pressure or cyclone, the air converges into the center. In other words, the air blows towards the central low pressure cell under the influence of the pressure gradient force. Cyclones produce cloudy conditions and eventually it rains. In the southern hemisphere, the air or the wind rotates in a clockwise direction around the low pressure at the center. You would have noticed that I've highlighted the letter C on the slide. C for cyclone, C for converging air, C for cloud, from which rain will eventually form, and C for clockwise rotation around the center in the southern hemisphere. If you have a look at the plan view of a low pressure cell, that being a view from the top of the cell, you will notice that the lowest pressure is found at the center of the cell. If this cyclone is located in the southern hemisphere, the rotation of the wind around the central low pressure is in a clockwise direction. And as the wind spirals in a clockwise direction, it gets closer and closer and closer to the center of this pressure cell, and this moving closer and closer to the center of the pressure cell is called the converging of the air. If you look at a cross section of a low pressure cell, you will find that the lowest pressure at the center, the air is converging onto the center. Once it gets to the center of the cell, it is going to rise, but in its rising, it's going to rotate in a clockwise direction. That rising air cools down, dew point temperature is reached, condensation occurs, we have the formation of cloud as a result of the rising air, and eventually if the cloud becomes saturated, it is going to produce rain. Once you have memorized the low pressure cell, remember that the following applies to a high pressure. If a low pressure is called a cyclone, then a high is called an anticyclone. If the air converges in a low pressure, it diverges in a high pressure. Cyclones produce cloud and rain. Anticyclones produce and have clear skies. Clockwise rotation of wind around the central low in the southern hemisphere, but anti-clockwise rotation of wind around the central high pressure in the southern hemisphere. A very common question is to explain or account for the wind direction at a particular place. Check if the weather station is close to a high or a low pressure and focus on the rotation of the wind around the center. In our example, this weather station is close to a low pressure, which you are assuming is in the southern hemisphere. Therefore, that northwesterly wind experienced at this particular place is caused by the rotation of wind in a clockwise direction around the central low. So to recap, low pressure is also called a cyclone. A cyclone is characterized by converging air, cloud and rain, and very importantly, the rotation of wind around the center in the southern hemisphere specifically is in a clockwise direction.